Hello all, good morning and welcome to the class. Today we'll get started creating EKS cluster with the Terraform code. We have already seen creating an EC2 instance from here, right? So we'll create an EKS cluster with our Terraform code today. And for this, we will be using some modules for Terraform. Let us search for some modules. Modules of Terraform, modules from Terraform. Let us go ahead with the modules to the official repository. And yeah, like we browse for providers till now, we shall use some existing modules. First one is VPC module. See, we can create EKS with our default VPC also, but let us create our own VPC, our own cluster, right? So when you go for the EKS module, here there were some examples available on the GitHub. If you see here, source code available. Okay, again, some examples of how to create a VPC, like any other features you need. Okay, here is the example of providing the address, name, CIDR block, and ASIS. See, always the best practice to create a VPC with public and private subnets. Private subnets to hold the Kubernetes workloads, to run the Kubernetes workloads, and public subnets to expose the cluster, to expose the endpoint, the load balancers, right? So these are the important features. And enable the NAT gateway, enable VPN gateway, and some tags if you want. Okay, so we'll use all this code to create a VPC first. Then we'll spin up a Terraform. See, some examples code is here available. Okay, like whatever you want to deal with, you have a lot of examples here. So let us start writing our code with using this VPC. I'm going to create a file called vpc.tf, VPC for EKS or whatever, some name. Okay, and also yes, obviously we need the provider for it. Provider, AWS, okay, some provider, and then the region. Okay, some region. Let's say we are going to create in South one. Let's let it be, okay? Here also we can create. And then now some initialize variables and all. Variables, passing the variables, will do everything. First, let's call the module. Module. Here you may give any name to your module. Okay, I'm just giving the name as VPC. This name can be any name of your choice. Here, call the module. Call the module. Right, this is the source, name, CIDR blocks. We can have all of this. Let me add these three. Okay, so source, some version. If you don't mention the version, it will use the latest version, or else you could use the version. Let me put some version which I am using is 3.14. Right, and some name like my VPC and the CIDR block. Okay, CIDR block we are hard coding for now. We'll later pass them as a values. And then ASIS, like availability zones. In which availability zone you want? I want to pick up this availability zone, from the AWS console. So we have something called data sources, right, to pick up these availability zones. If you are not sure, just check here for search here for search here for availability zones. Availability, yeah, see, availability zone. Let's search one more availability zones. Yeah, ASIS. See a list of availability zones, names or IDs in that particular region. It will be returned as a string. Okay, list of values in a square brackets. So I just want that to return some value. Yeah, see data, like we are using data for region, I would like to use data for ASIS. Let us see, we may just see some examples. See outputs, ASIS can be outputs. Yeah, see here. This is how you can pass the variables, right? So Similarly, so is the ASIS. Let me just use some data source here. Data, AWS availability zones, availability zones, availability zones. Okay, and I'm just giving the name as available. Okay, so yeah, that's all. That should return the availability zone. So here now, how do I refer a data source? If you remember, we have used for AMS data dot the name AWS availability zones dot available, right? Dot names that should return dot names that should return all the names of the availability zones. Then we have to define the private subnets. Private subnets. I would like to use some variables, so just let it be. Similarly, public subnets. Okay, and that's all. And then yeah, enable the NAT gateway and enable the DNS host names. NAT gateway is to allow the internet traffic. We can allow NAT gateway and all the subnets can be routed through single NAT way. Right? That's all. And yeah, to identify this particular VPC by our EKS cluster, we could add some tags for both subnets and private subnets. I mean, public and private subnets. See here. Tag. Okay, this is the tag I'm using. My app EKS cluster. It's a shared. Subnets also. I'm adding a same label. What is this label? See, whenever we spin up EKS cluster, it will be using something called Cloud Controller Manager. Cloud Controller Manager will spin up the EKS cluster and it need to identify which subnets it can use, which private subnets, which public subnets it can use for the cluster. So it will identify using this label. And yes, elastic load balancer. Okay, allowing public elastic load balancer for public subnets, internal load balancer for private subnets. That's all. That should create VPC with all the custom configurations. Just let us do a plan command. Before plan, we should first enable it, like Terraform init. It will initialize the new modules, everything. By the way, I should do one more thing. First, let us do, before running it, AWS configure. Okay, I have got the new account, right? So let me create some security credentials. Go to security credentials. Let us create a new security credential. Access key secret key already something is there. Let me just create one. Root user access are not recommended. It's okay. Create the access key. Download the CSV. Okay, done. So those credentials I should be using here, and I would be checking my EKS cluster on which region. US West 2, I believe, right? US West 2 is Oregon. Is it US West 2? Yes, Oregon. Okay, let us put some things here. Let me get the key, okay? Downloads key. Stopping the screen share for a while. Okay, so I have given those credentials. Now let us do Terraform plan first. Terraform plan. By the way, we have used some variables, right? We have to pass those values. Maybe I want to use this source as a variable, side block and everything. So let us also use those variables. Let us define them in a separate file, variables.tf. Or else let me just define here itself. Instead of this side block, I would like to say variable VPC side block. Right, then variable private subnet side block. And one more variable for public subnet. For public subnet. Public subnet. Now assign the values. I'm removing this. Var dot VPC side block. And then here var dot private subnet side block. And here var dot public subnet side block, right? So everything is good. Yeah, we need to pass these three variables from terraforms.tfvars. Just let me create terraform.tfvars. Okay, and let us assign all these values. See, depending on the region, okay, if your region has three availabilities, or generally will have three, so three AZs will be there. So for each AZ, there should be three private subnets, three public subnets, right? This is how it should be. For each AZ, there will be one private subnet, one public subnet. Suppose you have one region, okay, we are using US West 2. It will have three AZs. Three AZs means one public subnet, one private subnet for each AZ. So 3 into 2, 6 AZs. So accordingly, I have given here the network ranges. Okay, now let us do apply. Var dot private subnet side block. Terraform dot tfvars. Var dot private subnet side blocks. Okay, I have given here blocks. What did I use here? Okay, let me say blocks. Okay, because it was different, it was asking me for the value. Subnet blocks. Let it be. Okay, now plan. Okay, 20 resources will be created if you just scroll down. right? VPC, NAT gateways, everything, right? You can see all of these values. It will create all of these values, and our VPC will be created, which is compatible for EKS. Now let's create the cluster. For that, we shall use another module. This is VPC module. So let us search for modules. Search for EKS module. Yeah, if you see Terraform module to create an EKS cluster and associated resources. So again, how to use the module, here it is. Okay, module EKS you can call it. And there were examples, everything available here. Yes. Okay. So VPC, subnet IDs, you can pass all of them. Self-managed node groups means you have to manage your own worker nodes. You have to create the worker nodes. You have to take care of a cluster, everything are there. Okay. I mean, you have to take care of installing kubelet, Docker, everything. If you use managed node groups, this is the best option. It will create EC2 instances, I mean, worker nodes, which are from optimized EKS, right, AMI, so that it will have all the supported components needed for the cluster. Okay, so let us go for it, and yeah, let's create the cluster. Let us create one more file called eks.tf. Okay, so here again, module eks and the address from where you want to pull up, and let me write here all the resources. Yeah, you can get it from Terraform document. Okay, version of the module, some cluster name, cluster version, subnet IDs. Say subnet IDs are being from another module. So how do you call that? Right? So with the name of the module, see, my app VPC, I have given this name. Let me just add it here, the same, or else you may change it there. You have to call the same name. Okay, my VPC.private subnets, my VPC.VPC ID, because in that same VPC we need a cluster, not in any random VPC. Okay, and some tags, and it's EKS managed node group. You can give some name to your node group. I have given name, minimum size is 1, maximum is 3, desired is 2. So that a node group will be created with actually 2 nodes. Clear with this code, everyone? Please go through it and ask me. It was like everything is almost self-explanatory here. So this will create one node group. Node group name is dev. You can have any number of node groups as such. Is this clear? The code clear for everyone? Can you run the code? First, let us do Terraform apply. I mean Terraform plan. Something gone wrong, it's giving error. The module, yeah, see, because I changed the module name, VPC name, okay, it is saying it's not installed. So whenever you use a new module, first do Terraform in it. Okay, now do Terraform plan. Okay, so 50 components will be created, which will take some time, but let's create it with auto approve. It should start creating the cluster. Meanwhile, it creates a cluster. Okay, once cluster is created, we will deploy from Jenkins server, right? So let us get our Jenkins ready. Okay, it should be creating the cluster. Meanwhile, let us start our Jenkins server. I don't have a Jenkins server ready. It's a new instance. Meanwhile, I'll quickly spin up the instance for Jenkins. Okay. Meanwhile, it is creating everything. So let me do one thing. Launch instance. Okay. Let the name be Jenkins server. It is Amazon Linux 2 t2.micro. Key pair login. Create a key pair. Create a new key pair, which is of the PEM format, or it can be of PPK. First, let it be PEM. Later on, we can convert. Let it be AWS key. Create a key pair. Okay, it's downloaded. Security group. Allow all traffic. I want to add a rule. Let us edit. SSH and allow all traffic. There is an option to add rule. Okay. Allow all traffic. Launch instance. Yeah, meanwhile it was creating. And we have this PEM file, we need to convert this, right? Let us keep this key as well. I'm having this key into the SSH keys. Now let us use the quotation. Trying to download quotation. Okay, yeah, got it. Okay, so now put this file SSH keys, not this one. The one I have is this one, the one which is generated now. Now save the private key file. Yes. In the same folder is fine. Yes. Okay, done. Meanwhile, see the cluster is still creating. We can continue our work. And now I think I can connect this from Putty. Let us put this accept EC2 user. Sudo su hyphen. Fine. Now let us install Jenkins. Just give me 1 second. Okay, now quickly install Jenkins. Java should be installed, right? Java is not there. Let me install Java. By the way, it was asking for Java 11. Okay, let it be. Okay, I'm installing Java 8. Meanwhile, yes, cluster is still on the way. 6 minutes. It took 6 minutes. It's still creating. Meanwhile, we can install Jenkins. Alternative configs Java. Okay, I just want this path to set Java environment variable till 64. This is the one I need. Now go to HC profile, export. Export the variables. Export Java home. Okay. Oh. Then export path variable as well. It should be $Java home, then path. Okay, source, let's say profile. Now go Java home. We already did this, so I'm not explaining this part. We have already done this. Now go to Jenkins download. Okay, so here it is. Copy. Okay, and then download the keys. Okay, install Jenkins. So that should help us install Jenkins. Confirm it. Okay, cluster is still on the way. Meanwhile, we can check here. Okay, here is where Oregon region we are creating the cluster. Yes, see, cluster is active. It was creating. Here you can see all the information, resources, compute. Okay, we have created one node group with two instances were not yet ready. The cluster is still spinning up. Okay. Meanwhile, yes, Jenkins is ready. Let us start Jenkins systemctl start Jenkins. Systemctl start Jenkins. What is the problem? Systemctl start Jenkins. Okay. Let us check the status. Okay, fail to start Jenkins continuous integrate. Fail to start. I believe it was looking for Java 11. Let me try this. This is the command to install. It was saying use this command in Amazon Linux too. Okay, confirm. Okay, now let us try to start again. Let's say restart. We'll do systemctl stop Jenkins and start it. What's the problem? Status failed to start. Jenkins.service enter failed state. Jenkins.service failed to start. Status on. Alternatives config Java. Sorry. So this is also another Java we have. Let me just use this Java as a default. I'll also change the path, but just let me try. It was working. When you change it, the default Java means I need to use Java 11 for the new Jenkins. So let it start. Meanwhile, yes, cluster is ready, and it took almost 8 minutes plus 2 more minutes, almost 10 minutes. So cluster is ready. So you can check the cluster this way. Just go to the cluster. Okay, refresh it. You should see the nodes. Nodes are nothing but your instances, EC2 instances. No nodes. It was just loading. Just wait. Let's wait. Meanwhile, come to overview. See the server endpoint, certificate authority, CA for connecting to the cluster. Okay, all of them were created. And yes, 2 node cluster is ready. This is the node group name. And where is this node? Again, an EC2 instance. We are just going to that EC2 instance. See, AWS console, you can go to click this instance ID. You will go to EC2 console. See, EC2 management console in the same Oregon region. See, 2 instances might have been ready. Do you see that they belong to dev group t2.micro? Okay. And in which VPC they were? Let's go to VPC as well. Yes. Here is the VPC. Go to VPC management console. This is the VPC we have created for our cluster, my VPC. Okay. And this VPC might have got 6 subnets. You can check here. These are all the ones. Let us filter with my VPC. Right, 1 2 3 4 5 6. Do you see that? Total 6. 1 2 3 public and 3 private. Like I said, every AZ has got 1 public subnet and 1 private subnet, right? That is the requirement for a EKS cluster. See, you can also see the nodes, the default pods running, everything here on the UI. And we have given a label, right? Some label as a dev group. Okay, you can see all of that here. Okay, not only that, because I have created a cluster, service started. Meanwhile, I'll show you some more. So because I have created cluster from here, obviously I can connect get nodes. I can connect from my laptop because I have created cluster from here with the Terraform. Earlier we have created manually, right, using EKS Okay, you can run the command AWS EKS update kubeconfig. Okay, there is some command to update your config. Give me a second, I'll show you the command. Okay, that is the command, but what is the cluster name? Yeah, I think it was correct. Added. Okay, added this context to kubeconfig. So yes, now you can connect kubectl get nodes. Okay, perfect. We have already seen this, how to deploy load balancer service, everything, but now we'll do it through Jenkins. So done. But now my task is to connect via Jenkins server. So service started, I believe. Check the status. Okay, it was good. So it needs Java 11. Now let us exit from the browser to create our job. So this is the Jenkins IP. 8080 is a default port. Okay, you have to unlock it initially. Go to the server again. Okay, get this. And install the plugins. And on the Jenkins server, we need to connect to our EKS cluster. How do we connect? Anyone? Do you remember? We have already done that when we created cluster with EKS ETL. I have shown you how to connect. How to connect? Have we already done this connecting from Jenkins? I mean, connecting Terraform with Jenkins, already done this? Okay. Meanwhile, let me open our address book code. Yeah, here is the address book. We need to include Terraform stage, right? So earlier we have done this with EKS cluster, right? I mean deployment on EKS cluster. It could be deployment on EKS cluster, or else like whether you deploy it onto EKS cluster or whether you deploy it, call the code, whatever code, you need to include a call to Terraform, right? So we'll do that. Just let me remove all of this. Rather than modifying it, I'll just put the entire code. What we are going to do. See, cluster is done. And yeah. Actually, executing on a Kubernetes cluster from Jenkins is done, right? From Jenkins, we know how to run it on Kubernetes cluster. Now we need a Terraform stage included. So all of this remains as usual. See, let's say I'm deploying on EC2 instance. Whether you did this stage could be on a Kubernetes cluster or EC2 instance. This is the stage we need. Calling the Terraform code. Okay, providing access key, secret key, and then run Terraform in it and Terraform apply. That's all. And once it applies this, it may create EKS cluster or it may create EC2 instance, right? That EC2 instance public IP will be using for deployment. This is the catch here. Okay, so cluster part is done. We want to see running Terraform code via Jenkins. So let it finish. Meanwhile, any questions in the cluster part? Cluster is ready. We are not deploying it on the cluster. We'll deploy it onto EC2 instance because we need to pass the EC2 IP. So I'll show that. For Kubernetes, you don't need to pass anything. You'll just have to do kubeconfig file created on Jenkins server. That's all. So once this cluster is ready, you know how to deploy it on this cluster, right? We have already done that. So rather than doing the same again, we'll deploy it onto EC2 instance. So I would like to destroy this before, because cluster EKS cluster is a paid one. Just let me destroy this. Terraform EKS, which we have created just now. Okay. Once this cluster is ready, how to deploy from Jenkins, we have already seen. Whether you create from Terraform or whether you create from EKS how to connect from Jenkins, we have seen. So we'll deploy it onto EC2 instance. Destroy with auto approval. Meanwhile, it goes down. Yes, cluster is ready. Let's put something like confirm full name. Save and continue. Okay, now let's create a job. Pipeline kind of job. Let's say DevOps pipeline. Okay. Here some plugins may be missing. We shall do that. Okay. Here pipeline script from SCM. Get the repository URL. Let's go to GitHub. The address book. Okay. Because Git is not there here. Let us install Git. So it should work in some time now. What happened? Okay. It's a public repository, so then on the branch master, that's all right. So let's save it. Again, if you check, there should be no error because it has got Git available. Good. That's all is our pipeline. Now our job is to, yeah, it was deleting. Let me open in a new window. New window. We shall go to our address book code. Terminal. Okay. Oh, entire panel is gone. Okay. Right. So what is this code doing? Let us go here. Now we know this block, right? Packing the code we know, pushing the image we know, then deploying it also we are good. Now what this Terraform code will do? Running the Terraform code, we'll create a Terraform folder here and actually put the code here. Okay, that should spin up an EC2 instance. Okay, this line will spin up EC2 instance. Once EC2 instance is created, I'm using output values to grab the public IP and place it into this variable. Now this public IP will be used for running any other instance. Do you see that? Earlier we were hard coding this IP for deployment servers and all, but now we were doing this. Understood this code, everyone? Sleep for 90 minutes, because once instance is created, it will take some time to get ready, right? So we were allowing some time here. Just go through it and let me know. We don't need to hard code the deployment server. Dev server, yes, we will hard code. Dev server is where it is creating it. If you want, you can use Terraform for this as well. Okay. So let it be here. the dev server key. We need to create this key actually, dev server key. On EC2 instance, we need to, on Jenkins server, we need to create this key. The same key you may use for deployment also. Okay, we shall create that on Jenkins server. Okay, everything else is the old code, just using this public IP which we grabbed from Terraform. First, let us make sure we already have all these credentials on Jenkins. Let's go to the credential store of Jenkins. Manage Jenkins. Manage credentials. Let's create a new credential. Okay, which is of type secret, such username with private. I have given the name as dev server key. Okay, username is EC2 user. Enter directly. Add it. Okay, just open this as such case. Okay, this is the one. So let's copy this. Okay, done. And what else we have? Just go line by line. Image name, if you need not create a dev server IP, here we will put the IP address. One is a hard coded, like one is created manually. This instance is going to be created manually. AWS access key, secret key. Copy. Go to one more credential. This time it is of secret text. And this is the ID. Put the ID here. Get the file once again. Access key. What is this unacceptable characters? Okay. Yeah, space is there. Create one more of type secret text. ID. Let's go here. Secret access key. Right. So yeah, I think that is fine. Create one more EC2 instance. Cluster should be gone by now. Still. Okay, it was still deleted. Let it be. Let's come to the instance. Let me create one more for dev server. This is going to be where our EC2, image will be created. So yeah. Okay. So compile their unit test package. Okay. And then the Docker Hub credentials, by the way, yeah, we missed it, which is very important. So let us go ahead again to Jenkins. Manage Jenkins, manage credentials, one more credential, add credential. It should be of type username password. Username is and the password. Right? So Docker Hub credentials ready. Can we push the code now? Yeah, main thing, Terraform code. We need to put the Terraform code here. Where is our Terraform code actually? It is on the, here is the Terraform code. Let me show you. Yeah, Terraform demo, right? Here is the complete code. Okay, so this folder, we need to place it in the, this code we need to place. I would like to delete not Terraform. And what else? State files. Okay, let us delete. Let us create a new one. State files deleted. Log file also we don't need. Okay, seems good. Okay, we'll put this complete code. Create a folder called Terraform. Okay, so what we'll do is we'll just copy this complete code and in the address book in the Terraform folder. That's everything. Okay, that's good. Now we should see everything here. Yes. Okay, make sure it is all fine. Main module. Okay. And then passing the side block, forward, subnet, everything. And server script.sh to install Docker. But first check here in the web server which ports we were forwarding to 8080. Okay. So we have opened the port on 8080. So in the main.tf, okay, fine. Variables.tf server script 8080, fine. If that is the case, once you come to Jenkins file, we should be forwarding it to 8080 only, correct? Okay, because that port is open. And which key it was using? Just check the key, which key it was using. AWS, fine. Server script.sh, what is the server script.sh doing? Update, install. Okay, fine. Then what else? What is this server script is about? Installing Docker, which the previous stage is calling. Right? Previous stage is this one. Okay, where we have created instance manually. So yeah, I think it was good. Definitely few more modifications may be needed. We may know it better once we run that. So let us run. First do git add. Where are we running from? Address book, Terraform working copy. On server script.sh. It's okay. Git commit minus -tf code added. Okay. Git push origin master. Okay. Git status. It was all good. By the way, okay, now yeah, it is ready. We can run the pipeline. But this Jenkins server should have Terraform installed, right? We are running Terraform init here. So obviously Terraform should be there. So let us check if we have Terraform installed. It's anyway new instance. Terraform would not be there. Check once Terraform command not found. So let us install Terraform. Install Terraform on EC2. Go to the official documentation. Installing Terraform on Linux. Okay, it is Amazon Linux. So here is the command. Install yumit utils. And then, right, using yum configure, we will add the repos for Terraform. And once it is there, you could install Terraform. This Terraform code will create an EC2 instance on which Docker containers will be deployed. Yes, deploy server. Correct, deploy server. Deploy server is being created by Terraform. Build server we have created manually. Build server is where image is built and pushed. Okay. So now let us run the pipeline. Build failed. My Java. JDK not installed. My Java. Where is my Java used to workflow? Floor. Okay, I got it. This one. Do we need it? Actually, we were installing everything with tools, so I don't think we need it. Let us add commit push and let us see. Well, now MVN command not found. Okay, because see, we were doing compile and all with automated tools, right? So we need this now. Control C. Okay. See, for this block we need it. How do MVN compile MVN test do? Here we were installing with this script, right? But what about the things happening on the same server, right? So let us put some Java here. Through automatic installer, global tool configuration, add Java, my Java, and I have already installed Java 8 also, right? So I'll use that Java for building the Maven application. Native config Java alternatives. Okay, this one is used by Maven because our address book application needs this Java version. So this Java is not for running Jenkins, for Maven builds. So use it. Java 11 for Jenkins. Perfect. Maven also add some Maven. Let's say my Maven. Okay, the latest one is fine. Now let us build the pipeline. Again failed. What's wrong? Compiling the code. Git installation does not exist. Committed. MVN command not found. My Java. Git is the default one. Maven installation, my Maven. So, from where is this error coming? Console output. First stage compiling the code. MVN compile. Agent any means it should go to the master. Go to the server. CD workspace. DevOps. It should use tools. I mean Maven from tools location, right? Come out of the workspace. Go to tools. Tools did Maven is not installed. So why is Maven not installed? Manage Jenkins global tool configuration. Git Maven is there. JDK Maven. It was searching for default Maven. VN compile. Tools from predefined location. Maven. My Maven. Tool name my Maven. That is actually already we have initialized it. See, if you want to test anything, you need not go to your local. Okay, you need not make modifications and you could also try this way. Let me just try here for the tools, but it will not work, I believe. Just let me try. Console output. Again the same. MVN command not found. See, this time it has installed. Unpacking this to var lib Jenkins on Jenkins. On Jenkins. My Maven on Jenkins. It has installed this time. Earlier it does not install, right? So there should be a tools directory now. Yes. Okay, at least it has installed now, but it should go to my Maven and use this. So how to tell to use that Maven? My Maven. Where is your code? Your code is in the replay. Okay, this is the line I have. I should tell to use this Maven. Pipeline syntax once again. sh commands. sh. Let us go to the official document. Pipeline as code. It was not taking this Maven. Tools, pipeline syntax reference. Tools. Okay, see, it was telling. Yeah, that's what we did. We have given MVN, but MVN command is not recognizing. Is there any way we could set this Maven? Must be prefunded manage Jenkins global. We did that, and we have also given my Maven. But it was not using this Maven when we do this search. Tools block MVN version. Maybe, okay. It's in the tools block. Agent any. Okay, I think. Yeah. See, agent any. We have defined this for agent none, the tools block, right? I think I should add this one. This agent should know, right? We have defined it for agent any. This agent should know. It was all pushed, so let me try. Yeah, it was working because see what happened earlier. Under agent any, I have defined the tools, but now I'm sorry. Under agent none, I have defined the tools, but agent any is a different agent. So this should have the tools defined, right? So put that inside the block. It should spin up an EC2 instance. Meanwhile, let's check if cluster is destroyed. Yes, cluster is destroyed completely. Let me close this window. Also here, I should not see any cluster. All the VPC, everything should be gone. Okay. If you check the VPC in the same region Oregon, my VPC, all the 6 subnets, everything should be gone. Right? Only the default VPC. Good. It was all good. Now here I should see a new instance. This one is manually installed one which is working as a build server. Deployment server is automated with Terraform. Is it the same? No. This is the one. It is for the first time, right? Obviously it will take some time. Failure. Somewhere it failed. SH agent. Yeah, because this is because we didn't install SH agent plugin. This needs a plugin, right? If you remember. So manage plugins. Available. Yeah, let us search for SSH agent plugin. Okay, done. Meanwhile, the pipeline executes. It should be working. Build now. Tools block. Remember, tools block should be defined under every agent. If it is different, okay. Again, something went wrong. User credentials. Which stage is this? Okay, that is build success. Now it's a test stage, I think. User credentials SSH command identity added. The key agent started. Stopped. Third stage. Third stage is dev server key. Docker Hub credentials. Dev server key. Dev server IP. So the key is to be verified. Is the key correct? Dev-server underscore key. Let's check that. Manage Jenkins. Manage credentials. Where is that key? We don't have the key. Oh, okay. Here it is. Dev server key. Fine. Dev server key. Maybe let me put the key once again properly. Copy this. Place the key. Is it created with AWS key? This is the dev server. Check if we are using the right key. Yes, AWS key. Okay, let me rerun and see. Same. Binary agent on a remote machine. SH agent implementation. Identity added where lib Jenkins. Private keys created temporarily. Agent started. Auth sock. Stop agent stop. Let me check the security rules. SH all traffic. Outbound all. This is good. Just let me check the key. Restart. Easy to user. Jenkins. Workspace. That's a temporary folder. Temporary private key. Lib Jenkins. Initially, we'll be suppressing the keys. Strict host key checking no. Here also strict host key checking no. Copying the key. Something wrong with the key only. Manage credentials. Dev server key. Easy to user. And set auth. Yeah, this is what happening for us. Or agent killed. That is inside the Docker container. Such agent. With the credentials block. Credential ID. This is the Docker up credentials. Username, password. Service script.sh. Git push. Where is it going? Agent ID. So it is doing on the master only. This is happening for us. Identity file added. SH agent opened. SH agent started. And then echo agent PID 1227 killed. Stop. It was not, yeah, of course, it was not displaying the whole log. Just try from your end, it should work. Maybe the EC2 instance settings or something. Okay, I'll run this again tomorrow. We'll execute this phase tomorrow. Just try it. It should work from you, from your end. Maybe some settings were disabled or blocking. SH agent, security, all traffic, 22 ports were allowed, ports were open. Script, is it copied? Jenkins, workspace, DevOps. Server script is being copied here. This should be copied to the remote machine. Just let me check. One connect. Server script is not copied. Let me check if I could access from my system or not with the same key. This is the remote one. New session. I could access. Dev server key. We'll fix it tomorrow, okay? We do complete your pipeline till this much, okay? Placing the Terraform code and creating the structure. Run from your end, okay? See how this works. If not, I will execute this again tomorrow. Any more questions till this part from anyone? All right, then that's all for today. We'll continue from here tomorrow. Bye, everyone. Thank you all.